Hello everyone. Today we are going to start lesson number 6, chemical reactions. So we have discussed a large number of chemical reactions in the previous chapters. We have discussed about various like bigger entities when they break into smaller one, and again some reactions in which one element displays another. So all these reactions we are going to study in systematic way in this chapter. Earlier we have studied them, but not in a systematic way. So first, change in energy in a reaction. All the reactions are accompanied by a change in energy. What is energy? Energy can be in the form of light or heat. So either energy will be given or it will be absorbed. So a chemical reaction in which heat or light is evolved or is given out is exothermic reaction. And a chemical reaction in which heat or light is absorbed is an endothermic reaction. So when you touch a hot object, you feel burning because it is giving you heat. On the other hand, heat or light is taken. When you touch ice cube, the ice tends to melt when you touch it. The melting of ice is an endothermic process. So why a change in energy in a reaction? We know the two atoms in a molecules are held together by a force called chemical bond. So it is the atoms that takes part in the reaction. So there are two types of energy changes which occurs in a reaction. The first, breaking of bonds of reactant molecules, so as to set free the atoms for new combination for to form new products. And the second types of energy changes, new bonds or fresh bonds are formed because of new products are being formed. So reactants break to give free atoms, and then those free atoms combine to form new substances which are also known as product. So in first case, energy is absorbed, and in the second case, energy is given out. So these two processes are responsible for changes in energy. So energy required for breaking of bond of reactant is not as same as energy. So in both the processes, in breaking of bond and in formation of bond, the energy changes are not same, they are different. There's difference of energy changes. So when energy is given out in the form of bonds is more than that is used for breaking the bonds, the surplus energy is evolved and is called exothermic. But when energy is required for breaking of bond, if there more energy is required to break bond as compared to formation of new bonds, then difference in energy has to be compensated from outside. So energy has to be taken from outside. So the process will be exothermic. So depending upon the types of energy, you can say required or used, we can say that reaction is exothermic or endothermic. So we are going to see examples of exothermic reactions first. Burning, you know, is exothermic. It is the exothermicity of burning that makes a combustible substance of fuel. For example, hydrogen, carbon, CNG. In CNG, the main component is methane, so CH4 is written, and in LPG, the main component is butane, which is C4H10. So you can see H2O plus O2 when you burn it. Water is formed, carbon, oxygen when burned, carbon dioxide. CNG when burned, then it forms carbon dioxide and water. And LPG, when it burns, then it again forms carbon dioxide in water. So this is an example of exothermic change, burning. Next, how some active metals react with water. Some active metals react in a different way with metals. In an exothermic way, they evolve lot of energy and oxide is formed, as you can say, a metal, sodium, potassium, or calcium, all the three. When they react with water, then they are forming their respective hydroxides, potassium hydroxide, calcium hydroxide, sodium hydroxide, as well as hydrogen gas is evolved. And in this process, a lot of energy is given out. That's why it comes under the category of exothermic reactions. The next is dissolution of metal oxide in water. Metal oxides, why it is written basis? Because oxides of metal are basic in nature. That's why it is written basis. Oxides of metals are basic in nature and oxides of non-metals are acidic in nature. So bases like sodium oxide, calcium oxide, they react with water to form their hydroxides. Again, here also the hydroxides will be formed. Okay, the reaction of calcium oxide is known as quicklime with water gives calcium hydroxide, which is known as slaked lime, and the process is known as slaking of lime. So, what is slaking of lime? When calcium oxide it reacts with water to form calcium hydroxide, the process is known as slaking of lime, because from quicklime we get slaked lime. So the process is known as slaking of lime. Okay, so this is again a reaction which is exothermic in nature. The heat will be given out, or the heat, large amount of heat will be evolved. Then the next one is dissolution of non-metal oxide. As you see, acidic is written. So I told you the oxides of non-metals are generally not generally, but mostly acidic in nature. So oxides of non-metal, for example, carbon is a non-metal and its oxide is carbon dioxide. Sulfur is a non-metal, its oxide is sulfur dioxide and a sulfur trioxide. So all these three, when you see they react with water, they will form their respective acids: carbonic acid, sulfurous acid, sulfuric acid. So when metal oxides they react with water, they form hydroxides, or you can say they form base. But when non-metal oxide, non-metallic oxide, when they react with water, they are forming respective acids. The next is reaction between an basic and acidic oxide. The reaction between basic and acidic oxide. This is example, as you can see, and sodium oxide Na2O is a basic oxide and carbon dioxide is an acidic oxide. So when they two react, they form salt and evolve heat. Then salt here is Na2CO3, sodium carbonate. And in the second example, when calcium oxide, it reacts with carbon dioxide, then it forms calcium carbonate, also known as limestone. Again, it is a salt. So you can see that when basic and metallic oxide they react, they form salts and lot of heat is evolved. That's why it is coming under the category of exothermic reactions. Neutralization reaction, you must be aware of: an acid react with base to form salt and water, then the reaction is known as neutralization. So you can see here base is NaOH and acid is HCl. Then when they react, they form NaCl and H2O, salt and water. Similarly, base is potassium hydroxide, KOH. When it reacts with H2SO4, which is an acid, then it forms K2SO4 and water. So the nature of salt or what type of salt will be formed will always depend on the base or acid you are taking, and the water will always be formed in this case. So you see NaOH, HCl. So NaCl was formed and KOH and H2SO4. So K2SO4 was formed. So the salt will be decided by the base or acid being taken, and water which is present in all the reactions is the same. So all such reactions are exothermic reactions. There is an activity given over here. Take 5 ml of dilute NaOH solution in a test tube and add equal amount of dilute HCl to it. Hold the test tube. You will clearly feel that it has become hot. So they are doing the same reaction which is written the first reaction. They are doing it in practically. You take dilute NaOH and you take HCl and you mix the two and you hold that test tube in your hand. You will feel it is warm. The nature of the reason for it being warm is that it is a exothermic reaction. The heat is evolved. Next is reaction of an acid with metal carbonates. By performing similar activity as above, you can conclude that heat is evolved when acid act on carbonate or hydrogen carbonate, producing carbon dioxide. So you should remember one thing, that anything which is having carbonate or hydrogen carbonate, or also known as bicarbonate, will always give carbon dioxide as a product, as one of the products. Anything which has carbonates or bicarbonate, or also known as hydrogen carbonate, anything which has carbonate, bicarbonate, or hydrogen carbonate will always evolve carbon dioxide as a product, one of the products. So you see Na2CO3, when it reacts with HCl, then NaCl, a salt is formed, water is formed, and carbon dioxide gas is evolved. Calcium carbonate, when it reacts with HCl, again calcium chloride is formed, carbon dioxide is evolved, and water is formed. So as you can see, carbonates, when they react with acid, they form salt, water, and carbon dioxide. Salt, water, and carbon dioxide. The nature of salt will depend upon the type of carbonate we are taking. The nature of salt will depend upon the type of carbonate or we are using. Next is respiration. You know that respiration is a process by which our life goes on, in which glucose is broken down by oxygen to provide energy. So the reaction is C6H12O6, which is glucose, and the oxygen which you take from environment. Then this is the equation for respiration, that carbon dioxide gas is evolved, which is expelled out. You breathe out carbon dioxide, and water is also breathed out. Water vapor also is breathed out from your nose. So this is an exothermic reaction because again heat is released in this process. Rusting is in rusting, iron slowly combined with oxygen in the presence of moisture to form brown red hydrated iron 3 oxide. The chemical formula for rust is iron 3 oxide Fe2O3.XH2O. Here X represents the water, which can vary. So the reaction is exothermic, but it is very slow to let you feel its heat at any point of time. Now, next we are going to start with example of endothermic reaction. So when a combination of nitrogen and oxygen, when nitrogen reacts with oxygen in the nature, in the environment, when there is electric spark, then nitric oxide is formed. Okay, the next is it is an endothermic reaction because electric spark is used. Electric spark is a source of light energy. ऐसा नहीं है हमेशा heat use होती है. There can be both heat and light. So electric spark is a source of light energy. So hence the reaction is endothermic. Then thermal decomposition means decomposition by providing heat. Thermal word here it means by providing heat. So when metal carbonates like calcium carbonate, magnesium carbonate, or any carbonate, when you provide it heat, then always it will give carbon dioxide and oxide. As I told you, anything which has carbonate with it, always one of the product will be carbon dioxide. So again, we see here that calcium carbonate or sodium carbonate or magnesium carbonate, when you heat it, then respective oxides are formed with the evolution of carbon dioxide gas. Then photosynthesis, you know that it is a process by which plants prepare their food by using sunlight. So again, here light energy is being used. So this reaction again becomes endothermic. The equation for photosynthesis is given there. Now, endothermic physical processes, there are certain physical processes which are endothermic in nature. For example, melting of ice, it requires heat from outside, and so the boiling of water, so water gets converted to steam at 100 degree, but we have to heat it all along, that is until it is converted into steam. Then dissolution of ammonium chloride, ammonium nitrate, of glucose, all these examples is a common example of such process. It is a common example of endothermic process. If you put little bit glucose on your tongue, then you will feel cool because the glucose will take heat from your tongue and hence will be endothermic process. So stir any of these substances in a glass of water and hold the glass in your hand, you will feel it has become cold because these are endothermic reactions. Some common observation, and exothermic reaction are more common than endothermic. Once exothermic reactions begin, they continue on their own, but endothermic reaction do not. You have to provide, for endothermic reaction, all you have to provide the source of energy throughout the reaction. You cannot remove a source of energy between the reaction, but exothermic reaction, once they started, they just need initiation. You just need to initiate them. They will go on their own. Okay. Then example like this nitrogen combined with oxygen to form nitric oxide only as long as there is electric spark. If there is no electric spark, the reaction will stop there only. Similarly, photosynthesis, as long as there is sunlight, the reaction will take place. When there is no sunlight, the reaction will not occur. So these reactions are exothermic reactions. They depend on the energy source first of all, and this energy source should be continuous. If you break the source of energy in between, then the reaction will stop. So continuity of energy is required in endothermic reaction, but this is not the case in exothermic. You just need to start the reaction and it will go of its own for till the completion of the reaction. Most exothermic reaction to have to be initiated. Same thing I was explaining. They just need initiation. They just need to be started. They just need a kick. After that, they will go on of their own and they will go on till the complete reaction has taken place. So types of chemical reaction. Now we're going to start. The first is combination reaction, in which two substances combine to form a product. Simple. In combination reaction or synthesis, two or more products add up. Always there will be two reactants and one product. So some elements like hydrogen, carbon, sulfur, phosphorus, calcium, and magnesium, when being burnt, they form their oxides. So this is a direct combination. Carbon plus oxygen give carbon dioxide. Sulfur plus oxygen give sulfur dioxide. Calcium plus oxygen give calcium oxide. So all these are combination in which two reactants combine to give a product. So burning of carbon, some charcoal in deflagrating spoon. Just see, they are burning carbon. So when the carbon is burnt in the presence of oxygen, here, carbon dioxide gas will be evolved, and the presence of carbon dioxide gas will be checked by lime water, which will turn milky. So, this shows that burning of carbon dioxide gas is produced, and the test for carbon dioxide is that it will turn lime water milky. So, close the mouth of the jar with a lid when all the carbon has burnt. Invert the jar and place it in a trough containing clear lime water and open its mouth inside the liquid. As you can see, you have taken a jar. If you have, when all the carbon has burnt, you cover the lid, and by covering the lid, you invert, ulta karna hai इसको carbon dioxide वाले the container which has carbon dioxide in lime water. So we will see that lime water rises in the jar and becomes milky. So this proves that carbon dioxide gas is formed. Next is burning of magnesium. When magnesium burns, with dazzling white flame, the magnesium oxide formed deposit as a white smoky solid. As you can see, the white solid will be deposited on the wall of this jar, and the white solid is magnesium oxide. So magnesium burns with dazzling white flame by for with the formation of magnesium oxide, and the magnesium oxide it gets deposited on the walls of the jar. Then rusting, when you if you have a piece of iron when it is left in moist in air and it has presence of moisture, then it will slowly change to rust, hydrated iron 33 oxide Fe2O3.XH2O. So again, this is a reaction in which we get rust, and X can vary means the amount of water can vary. So this is also a combination type of reaction. Now next is combination of element with chlorine. Specifically, we are going to study combination reaction with chlorine. So because it is a very active non-metal, greenish yellow gas. So Na when it reacts with chlorine, NaCl. Fe when it reacts with chlorine, FeCl3. Hydrogen when it reacts with chlorine, HCl. And phosphorus when it reacts with chlorine, PCl5. So sodium chloride, sodium iron 3 chloride, hydrogen chloride, phosphorus pentachloride. These are the product forms. This is a combination reaction because two reactants give single product. Now again, next is combination with sulfur. Then iron it reacts with sulfur, then it form iron sulfide FeS, simple combination reaction. Then combination of oxides. When oxides they combine with water, then they form respective acid. This already we have discussed earlier that oxides of non-metals which are acidic in nature, when they react with water, they always form respective acids. So carbon dioxide combined with water to form carbonic acid, and the oxides of metals they form hydrogen. This also we have discussed that oxides of metals when they react with water they form respective hydroxides. Okay, when carbon dioxide is passed through water for some time, the water turns blue line witness red, showing that it contains acid. So this is a test for acid. When blue litmus change to red in color, this is a test for acid. At the same time, lime water, which is prepared by adding water to quick lime, is a solution of calcium hydroxide, and it turns red litmus blue. Thus, calcium hydroxide is basic in nature. So acidity and basicity can be checked using litmus. Acidic turns red, acidic substance, they will turn blue litmus red, and basic substances will turn red litmus blue. So you underline this is a test of acid. The next type of reaction is decomposition reaction, in which a large molecule will break into smaller one. In decomposition reaction, one substances break down into two or more simpler substances. The first example is decomposition of water, which is known as electrolysis. Electrolysis is a process in which a substance is decomposed or broken down with the simpler substance, specifically means by passing electric current. So that's why it is called electrolysis, because larger molecules will break into smaller ones by passage of electric current. So as you can see, water when electrolysis or current is passed through it, it will be changed into hydrogen and oxygen from the one it is formed, and they will be collected. Hydrogen will be collected in a negative electrode and oxygen will be collected in a positive electrode. We add some acid to water, or you can say we made the water acidylated water so that it is easy to conduct the reaction. Okay, the gases start collected in the test tube. You will observe now, since you know we use more of H2 plus O2. So as you can see, gases start collecting in the test tube. You will observe that the volume of gas collected over negative electrode, as you can see, the gas collected over negative electrode is more or is twice than that collected over positive electrode, because you know when water is formed, then we use 2H2 plus O2, so more amount of hydrogen is used. So similarly, on the negative side of electrode, we can see more amount of hydrogen gas is collected as compared to oxygen. So when you stop passing the current, cork the test tube inside the water and take them out, perform the following experiments. Now we will test that which type of gas is collected. The first gas, the gas which is collected with negative electrode, you bring a lighted match near the mouth of the test tube, it will burn with pop sound. So this is a test for hydrogen. When a burning matchstick is brought near hydrogen, it burns with a pop sound. So this is test for hydrogen. So we are confirmed that on negative electrode we have hydrogen. Then when we test for oxygen, if you bring a glowing matchstick near the mouth of test tube and remove the cork, the matchstick gets lighted. So the gas is oxygen. So this is a test for oxygen. If you bring a burning matchstick, then it will burn more. So since we have done the test for both negative and positive electrode, then we have confirmed that the gas collected over them are hydrogen and oxygen. So this is electrolysis of water in which a larger water molecule breaks down into give smaller elements from which it is formed like hydrogen and oxygen. And it is collected in the ratio 2 is to 3 as it was initially formed. Now, baking soda decomposition. Baking soda is sodium hydrogen carbonate NaHCO3. When it is heated, it will form sodium carbonate, water, and carbon dioxide. Again, you can see here, like I told you, wherever there is sodium hydrogen carbonate, whenever there are carbonates or bicarbonates or also known as hydrogen carbonates, always carbon dioxide gas is involved. So again, here you see that sodium hydrogen carbonate, when it is heated, then carbon dioxide gas is evolved. Again, you see now potassium chlorate KClO3 when it is heated, then it forms KCl plus 3O2. The next is displacement reaction. In displacement reaction, one element will displace another from its compound, and how it will displace will depend upon the activity series given here. Okay, the higher an element in the series, the more active it is, and the lower the element in the series, the least active it is. So you can say potassium is the most active element, and gold, Au is gold, is the least active. Gold is the least reactive element. It does not react with anything. So it has been observed that more an active metal displaces, it is, you should remember that an active metal will always displace a less active one from its compound. Okay, so an active metal like sodium, potassium, calcium, when they react with water, they formed hydrogen gas and potassium hydroxide. Magnesium, which is less active than above non-metals, only react at high temperature. As you can see, sodium, potassium, calcium, magnesium. Magnesium is the last among K, Na, Ca. So it reacts certain conditions under certain conditions only. So when placed in steam, a burning magnesium ribbon continues to burn, forming magnesium oxide and hydrogen. In this reaction, a magnesium atom displaces two hydrogen atoms and takes their place. Okay, so now next is a less active metals like now when we talk about less active metals like magnesium, zinc, iron, they easily displaces hydrogen from dilute hydrochloric or sulfuric acid because they are above hydrogen in the reactivity series. Zinc react with HCl to form ZnCl2 plus H2 and iron react with H2SO4 to form FeSO4 plus H2. So all these magnesium, zinc, iron, they displace hydrogen from acids because they are above hydrogen in the reactivity series. So displacement of copper from copper sulfate by iron or zinc. When iron knife or nail is placed in copper sulfate solution, there is a brown-red deposit of copper over iron object as you can see in the figure. After some time, the blue color of the solution has changed to green owing to the formation of iron 2 sulfate. So when iron reacts with copper sulfate, because iron is above copper in reactivity series, so it will displace copper to form Cu alone and FeSO4. So since iron is above copper in the reactivity series, it will displace copper and takes its place. So it has displaced copper and thrown it out, and instead of it formed FeSO4. Also, zinc is above copper in reactivity series, but reaction is colorless. So you can see that zinc, when it reacts with copper sulfate, again it can displace copper from its copper sulfate and take its place. So copper is formed and then ZnSO4 is formed. Next is double displacement, in which double displacement is taking place. The positive and the negative radicals of the two reactants are exchanged, leading to the precipitation of product. Double displacements are very fast and precipitate is always formed. As you can see, reaction between silver nitrate and sodium chloride. Silver nitrate is AgNO3 and sodium chloride is NaCl. Here, now double displacement will take place. Ag will combine with Cl and Na will combine with NO3. So AgCl plus NaNO3, as you can see, exchange of radicals has occurred. We have studied radicals in great detail. Positive radicals were Ag plus and Na plus, and negative radicals will NO3 minus and Cl minus. So positive radicals have exchanged their negative ones. You can say there is an interchange of radicals. That's why it is called double displacement, and there will be always a formation of precipitate. As you can see, white color. The reaction between barium chloride and sodium sulfate, barium chloride is BaCl2 and sodium sulfate is Na2SO4. Again, you see barium and sodium are the positive radicals and Cl and SO4 are the negative radicals. So the exchange of radicals occur. So BaSO4 and NaCl is formed as a product. The solution initially appears white but gradually becomes colorless as precipitates settle down. Next is neutralization reaction. The reaction, this is a category of reaction in which an acid will react with base to form salt and water. So you can see the acid as well as base lose their properties to form salt and water, which are neither acidic and nor basic. The product which are formed, the salt and water, the product which are formed as a result of neutralization reaction are neither acidic nor basic. They are neutral. So that's why the reaction is known as neutralization, because it gives neutral products. Acid and base, they were together, they have their own identity, but after the reaction, they are neutral. They form salt and water, which are neither acidic nor basic. So in this experiment, we are taking dilute NaOH and phenolphthalein as an indicator. The phenolphthalein is an acid-base indicator. It will indicate the formation of acid or base. So as you can see, dilute NaOH, in that we put phenolphthalein. So pink color of phenolphthalein shows that the solution is basic in nature. So dilute NaOH, as you know, is base, and in it, if you add phenolphthalein, then it will give pink color, so which makes you sure that this is this is a basic solution. So now we add HCl drop by drop. We will see, since now water and salt will be formed, so the color will change from pink to white or colorless, not white, pink to colorless, and the solution is neutral. So this shows that change in color from basic to colorless shows that the basic nature has lost. So neutralization is always formation of neutral products. So that's why it is neutralization reaction. Now let us see oxides and their nature. Whenever a metal or a non-metal it reacts with oxygen, then it forms oxide. Whenever a metal or a non-metal it reacts with oxygen, it forms oxides. So they can be basic oxide, they can be acidic oxides. So metals, they generally form basic oxides, and non-metals, they generally form acidic oxides. So the methods of preparation is by direct combination, same combination reaction. Metals, they react with oxygen to form H2 plus O2 gives H2O, C plus O2 gives CO2, S plus O2 gives SO2. These are non-metals. Whereas on the other hand, when the metals react with oxygen, they form oxides, like magnesium oxide, calcium oxide. Same way. Next is by thermal decomposition. ZnOH whole twice, zinc hydroxide, when it gets heated, then it forms zinc oxide in water, and copper hydroxide, when it heats, gives copper oxide in water. The change is color from blue to black. Similarly, when we talk about carbonates, in carbonates, always you see there will be evolution of carbon dioxide gas. COCO3 gives heat, gives CO plus CO2. ZnCO3 plus heat gives ZNO plus CO2. So oxides are formed, metal oxides are formed, and carbon dioxide gas is evolved. Exception is Na2CO3 and K2CO3. Then next is sulfates. Whenever you hit sulfates, then trioxide will be evolved. As you can see here, CuSO4.5H2O is blue in color. Exception is Na2SO4, K2SO4, and many others. Similarly, for nitrates, there will be NO2 gas evolved, and oxides will be formed along with formation of oxygen. NaNO3 and KNO3 on being heated decompose to NaNO2 and KNO2 respectively plus oxygen. It is left to you to write the chemical equation for the reaction. On being heated, lead nitrate gives brown yellow fumes. The brown yellow fumes here shows formation of nitrogen dioxide NO2. Now let us see classification. Oxides has been classified in many ways. Here we will take up a classification based on their acidic character. Oxides are neutral, which are neither acid nor basic. Then acidic, basic, amphoteric means which are both acid and base. So neutral oxides are only four in number: water, carbon monoxide, nitrous oxide, and nitric oxide. They are neutral. They are neither acid nor basic. You should remember them. Then acidic oxides are oxides of non-metals and general are acidic. Reaction, they dissolve in water to form acid. This many times we have come across that non-metallic oxide, they react with water to form acid. Okay, and which neutralizes base to form salt and water. Like CO2 is an acidic oxide. When it reacts with water, it forms carbonic acid, sulfur. This many times we have came across in this chapter. SO2, when it reacts with water, it forms sulfurous acid, and SO3 forms sulfuric acid. Dinitrogen pentoxide N2O5, it forms nitric acid. So a compound that is obtained by removing element of water from the acid is called anhydride. So if you remove water from an element, then it is anhydride. In other words, the anhydride of an acid is compound which adds up to form the acid. Thus, like carbon dioxide is an anhydride, and if you add water, it forms H2CO3. SO2 is an anhydride. Anhydride means which does not have water. So when water is added, it forms H2SO3. SO3 is again an anhydride, it forms H2SO4, and N2O5 forms HNO3. You know that acid turns blue litmus red, acetic oxide turns moist blue litmus paper red. They first add up moisture of litmus to form acid, else you can see a solution of blue litmus. So reaction with base acidic oxide, when they react with basic oxide, they form salt. This also we have came across that acidic oxide they react with basic oxide, so you can say they form salts. Basic oxides are the oxides of generally metals. They react with this also we have done that they react with acids. Non-metallic oxides when they react with acids they form sulfate salt, and Na2SO4 and water, always water will be involved, and MgO plus 2Xl gives MgCl2, CO plus CO2 gives CaCO2. Basic oxides which are soluble at least to some extent turns moist red litmus paper blue. Thus, a freely soluble metal oxide like Na2O, a less soluble one like CaO, and only slightly soluble oxide like MgO will turn moist red litmus paper blue, but the insoluble CuO does not. All these are bases. And photoric oxides are those which behave like both acid. They will behave like base in the presence of acid, and they will behave like acid in the presence of base. So they are aluminium oxide, zinc oxide, and lead. Okay, so base as you can see ZNO plus H2SO4, then it will behave like acid ZnSO4 plus H2. PbO in the presence of acid will behave like base. It forms PbNO3 whole twice plus H2O. But when they are present in the front of base, now we have taken base NaOH and we have these amphoteric oxide. Now you see they will behave like acid, so they form Na2ZnO2 plus water, and NaOH which is a base in front of it, it will behave like acid to form Na2PbO2 sodium plumbate plus water. So let us see the activity. Take about 3 to 5 grams of zinc carbonate, ZnCO3 in test tube and heat it. So when you heat it, the white solid turns yellow to form zinc oxide. You cool it, then you will observe that ZnO is formed. Now, on being strongly heated, ZnCO3 decompose to ZnO and CO2. Now divide the residue of ZnO in two parts and add some. Now we have taken ZnO and now we have taken divided the residue in two parts. In the first part we add HCl, then we see ZnCl3 is formed, ZnCl2 is formed, and the second one we take NaOH and we say Na2ZnO2 is formed. So as you can see, ZnO is same for both, but depending upon you take acid or base, they change their behavior. In front of acid, they behave like a base and form ZnCl2, and in front of base, they behave like acid and form Na2ZnO2. Okay, so so this proves that zinc is amphoteric. Second one is for PbCO3. It will change to yellow color PbO. Again, you divide it into two parts. In the first part, we will add dilute nitric acid, NaNO3. We do not use HCl or H2SO4 because the salt PbCl2 and PbSO4 would be formed, which being insoluble would form a crust over solid PbO and preventing it from reaction. So in this we should remember that always you use nitric acid NaNO3, never use HCl or H2SO4 because HCl and H2SO4 when they react with lead oxide they will form products PbCl2 and PbCSO4, and these products are insoluble and hence reaction will stop after some time. So hence we don't use HCl and H2SO4. We use only sodium hydroxide, nitric acid. Then in the next test tube, you add some NaOH solution to other part and shake well. You will see that a colorless solution of sodium plumbite Na2PbO2 is formed, which shows its acidic nature. Okay, so you can see in the figure it is shown. Same is for ZnCO3 and PbCO3. Only the changes of product. You take it, you heat it, you form oxides ZnO PbO. You divide it into two parts. You add acid to one, you add base to one. The one which you add acid in that, this oxide will behave like base, and the one which you add base, the oxides will behave like acid. So amphoteric oxides are those which can behave as acid in the presence of base, and they will behave like base in the presence of acid. So here we finish this chapter. So I hope and I request, or you can say I'm ordering you people to see the video repeatedly and also just to practice the equations. Thank you.